What's the problem with the ASCII table? Well, if you look carefully, you will see that we can represent here textual information in English, but we can represent information from another languages. For example, we don't have accents here. We can't represent an Spanish word like, for example, mm, this patata. We won't be able to write this in order to represent this using ASCII code. So what do they did? Well, at first, remember that we were using only the first 7 bits of the byte. We only have from 0 to 127. So they used the additional byte to represent still more chars. In this case, if we use 1 bit more, we are multiplying the amount of information we can represent by 2. So instead of 128 characters, we had 256 characters. That those are the characters from 128 until 256 is the extended ASCII table. So we have here an example. This is another page. We have the control characters we have seen at first using for communications. We have the printable characters from 32 to 127. We have the letters, the numbers here, some other symbols like percentage, division. And after that, we have the extended ASCII codes. Okay, and we have a set of new characters that we can use to represent characters in other languages. For example, we have here the accents, uppercase accents and lowercase accents. So using the extended ASCII table, we will be able to represent a text in Spanish. We have the ñ here, ñ, somewhere is the uppercase ñ. So, but what happens? Okay, we can represent text in Spanish and maybe another languages like French. I think French uses some accents, reverse accents on Valenciano, whatever. But we have many more languages in the world. Take a look, for example, at the Cherokee alphabet. Okay, this is a completely new set of characters to represent. And you could say, okay, who cares about the Cherokee? Well, you have, for example, the Hindi alphabet. The Hindi alphabet, it's as you can see, it doesn't seem it's not similar to the Occidental alphabet, and there are 1,000 million of people who use Hindi. Or you can take a look to Japanese alphabets. They use 3 different alphabets: hiragana, katakana, and kanjis. For so it's not enough 256 characters to represent the characters for each language. So what do they did? But at first they invented something called the code tables. What's a code table? Remember that ASCII is a table that matches a number with the character representation. For example, the 65 is an A. Well, if you need a different set of characters for another language, you can create a code table. So, for example, there are some code tables used like Windows 1252, or you have, for example, the ISO tables 88, I don't remember the name, 59.1. You can have a different tables, and what do that mean? What do that means? That in this table, a character, for example, 131 could represent an ñ, and here the same number could represent a completely different character. So you can have, if you need Cherokee characters, you can have the Cherokee table, and you can write here the Cherokee syllabic characters and assign each one a number. For example, 25, whatever. So when you save or read information, you need to choose a code table to see what's the real representation of the numbers included in the file or in the stream of information you are decoding. And there is still another problem. Remember that we are using a byte for represent each char, and a byte gives us 256 different characters. But there are languages that have much more that than 256. For example, in Japanese, we have the kanji alphabet, and there are around 80,000 different characters. For example, this is a list of 1,000 kanjis. You need, for example, to print, you use this character, you need mixed, is this one. So it's not enough to have only a byte because we won't be able to represent all the Japanese characters, the kanji characters. So we need more than a byte. You need to n bytes to be able to represent the charts of all the different languages in the world. So we need a completely different system for represent characters if we want to cover all the possibilities that there are in the world.